All right, the last part of using a bell curve is understanding what a standard normal distribution is. So a standard normal distribution has a mean of 0 and a standard deviation of 1. Okay, this means that our values go up and down by 1, mean at the center of 0, 1, 2, and 3, and to the left, -1, -2, and -3. Okay, and this can be applied to any standard deviation table. So we're going to standardize data using z-scores, a data value x from a normal distribution with a mean, and remember we are using the x bar, so that should be an x bar, and standard deviation of sigma can be standardized by finding its z-score. So what is the formula for z-score? In order to find z-score, you are going to take the data value, subtract the mean, and divide by the standard deviation. Okay, this is the formula we're going to be using to identify z-score. So a z-score tells how many standard deviations a data value is above or below the mean. The area under the standard normal curve represents the percent of data that falls under the data value associated with the z-score. Okay, so why would we use z-score, right, if we know the empirical rule, which is the 65, 90, 68, 95, 99, 7 rule? This is what we learned in the previous lesson. Let's look at example 2 that you did here using the salaries, right? What if I asked you the percentage of data that fell below $68,000? $68,000 is not an applicable standard deviation, so we can't make those calculations, right? This is where z-score comes in. Using z-score, you can make or find the percentage of data below that value in any given normal distribution. Okay, so for example, it says locate the specified z-score on the curve above, then shade the region below each. Well, for A, it says z equals -3.2. Well, if we look for -3.2, I know that -3.2 is going to be somewhere over about here, 3.2. And we're going to shade the region below. That means that anything to the left of here is below 3.2, -3.2. Okay. If you look at B, z is equal to 2.1. Find 2.1. So I'm going to say 2.1 is about here. Okay. And everything to the left would be all of this portion. Okay. The rest of the bell curve. So this is how we identify the percentage using z-score. Okay. This is a standard normal table. The standard normal table gives the percentages of data that falls below a data value given its z-score. So example 1 says to give the z-score for each of the following percentages. The first one, 34.46%, look in the table, right? Identify where is 34.46%. If you notice, the table is given in decimal format, so that means I can go up here and I have found 0.3446, which is equivalent to 34.46%. Okay. Now, where is it located? You're going to do that cross section on the left and above. Okay. And you can see that it's telling us it is located at -0.4. That means the z-score for that percentage is -0.4. Then if we look at 94%, well, where is 94%? Do you see a 94%? The closest one would be this one, right? 94.52. We are rounding in this case because there is no exact 94%. So where does that fall? We look at the left and the right values, and that shows us that it is located at 1.6. So the z-score in this case is 1.6. And finally, looking for 0.005%. Where is 0.005%? Here we go. Okay, look to the left, look above. Where does it fall? It falls at negative 3.3. So this is our z-score. Okay, now we can do the same thing in the opposite direction. Example 2 asks us to find the percentage. So for example 2, we are looking at a z-score of 0.5. So I'm going to go in and highlight 0.5. So here's my 0. Here's 0.5. And you can see that it falls at the percentage of 0.6915. So a z-score of 0.5 has a percentage of 69.15%. Okay. Doing the same with 1.8. I'm going to go over to 1. It's already highlighted. All the way over to 0.8. Find that intersection. And you can see that it intersects at 0.9641, which means it has a percentage of 96.41%. Okay, now what this is telling us is that given the bell curve, I have to do it small here, given the bell curve, here's 0, here's 1, here's 2, at 1.8, which would be about here, okay, 1.8, this is telling us that this is 96.41% of data. You have to remember this. It is the data to the left of the z-score. Okay, and finally, looking at negative 0.3, well, here's my negative 0, here's 0.3. You can see that that has a percentage of 0.3821, so 38.21%. Okay, all right, hit the pause button. I'm going to erase my highlighting up here and go ahead and find the percentages for A and B. All right, so these examples were a little bit different because it did ask you to find the percent of data between the given values. So what did you have to do? First of all, you had to find the percentage of each z-score. So for A, you had 0.9, which has a percentage of 81.59. And for 1.7, which has a percentage of 95.54, remember we are looking for the data in between. So subtracting those two gives us a difference of 13.95%. Which means 13.95% of data is located between these two z-scores. Okay, same thing for B. Identifying those values, find the percentages and subtract, and you get 0.06% of our data within those two values. All right, example 4 says, suppose the heights in inches of women ages 20 to 29 in the US are normally distributed with a mean of 64.1 and a standard deviation of 2.75. Find the percent of women who are less than or equal to 65 inches. Okay, now when we think of our bell curve, right, our standard normal bell curve, you have to create the z-score in order to identify these given values because 65 inches is not in the standard deviation, right? If you create a bell curve, that means you have 64.1 in the center plus 2.75 takes us all the way up to 66.85. That's not 65, so we need to find a z-score. Remember the formula for z-score? You're going to take your data value, subtract the mean, and divide by the standard deviation. Okay, and if you need that formula once again, Z-score equals data minus the mean divided by standard deviation. This gives us a Z-score of 0.32. Okay, now looking at our table, I'm going to go back here. Looking at our table, we don't have 0.32, right? We're rounding to the tenths. So if I go 0.3, you get 0.6179, which translates into about 61.79% of the data under 65 inches. Now, part B says find the percent of women who are at least 65 inches. All right, so this is where A and B tie together because remember, the Z-score is going to give you the percent of data below your data value, right? So in this case, 61.9% of our data is below 65 inches. Well, how do we find when X is greater than 65 inches? This one does not require Z-score. This is a simple computation of taking 100% minus 61.79% and subtracting. 38.21% is our answer. Okay, now why did we subtract and not find Z-score? Because we already had the percentage below. So the percentage below plus the percentage above is what gives us that full 100% of data. Okay. Part C, find the percent of women who are between 60 and 63 inches tall. Okay, once again, 60 and 63 do not fall within our standard deviation count, so we have to find Z-scores for both of these data values, right? And the way we do this is I'm going to start with Z of 60 and apply it. So 60 minus 64.1 divided by 2.75. Enter that into your calculator and you get about negative 1.5. Okay. Now that I'm working with this one, I'm going to flip back over to my table. Go to negative 1.5. So negative 1.5, and I get 0.0668. And I'm just going to write that down. 0.0668. That's our percentage for 60. Then we're going to do the same for 63. So the Z-score for 63 is 63 minus the mean, which is 64.1, divided by the standard deviation of 2.75. Enter that into your calculator, and you get a decimal value of negative 0.4. Flipping back over to my data table, looking at negative 0, erase this one, negative 0.4 takes us to 0.3446. 0.3446. Okay, now how do we find the data between 60 and 63 inches tall? We're just going to subtract, find the difference. So 34.46% minus 6.68% gives us a total of 27.78%. So 27.78% of our data lies between 60 and 63 inches tall. Okay. Now D, find the percent of women who are no more. Clue, no more, that means we're looking for less than, right? So our data has to be less than 66 inches. Again, 66 does not fall into that category of 64.1 plus 2.75, so we have to find Z-score. Z-score of 66 is 66 minus 64.1 divided by 2.75. Enter that into your calculator and round to the tenths, and you get 0.7. Look at your table Okay, and my table at 0.7 shows me that my percentage is 0.7580. 0.7580, which means that 75.8% of my data falls below 66 inches. And finally, for E, find the percent of women who are less than or equal to 61.6. So we're looking at all data less than or equal to 61.6%. Again, Z-score is 61.6 minus 64.1 divided by 2.75. We get a total of negative 0.9. Look over at your table and go to negative 0.9, and you can see 0.1841. 0.1841 is our decimal value, which means that 18.41% of our data is less than or equal to 61.6 inches tall. All right, so we did example 4 together, all of it finding z-score and applying it to identify percentage of data. Go ahead and do example 5, A, B, C, and D. Find the z-scores, find the percentages, and then come back and check your answers. All right, here are the answers you should have for example 5. And a couple of these were tricky, right? You had to really pay attention. So A, you should have 57.93%, should have had no problem with that. And C, you should have 15.92%. Again, you should not have had any trouble with that. B and D were the tricky ones. So let's talk about B a little bit. B tells you that Brand scored higher than 86% of the students. It's already in percentage form, which means you had to find the z-score. And in this case, 86% correlates to a z-score of 1.1. So that means we are finding his score, right? So that's our data value. Now, setting it up using the same formula, z-score of 1.1 equals the data minus the mean divided by the standard deviation, it becomes a simple algebraic equation. We're solving for x. Multiply 10.9 on the right, and you get 11.99 equals x minus 71.81. Add 71.1 to the other side, and you get 90.09%. So that means that his score was about a 90%, right? Teachers don't write 90.09% as test scores, so we would say he scored 90%. For D, it tells you that if Michael scored a 91%, right, what percent of the students scored higher? Remember, z-score gives us the value below. So we still use the same process. You find the z-score 1.2, which means that 88.49% of students scored below 91%. How many scored above? All we do is subtract from 1, or subtract 100% minus 88.49%, and you get a total of 11.51%.